Every day we deal with forces. Okay, when you ride your bike, your foot pushes against the pedal, the push makes the bike move, right? When you drop something, it's pulled to the ground by gravity. So a push or pull is a force. A good definition for force is a push or pull in a particular direction. Forces affect how objects move. They may cause motion. They may also slow, stop, or change the direction of an motion of an object that is already moving. Forces can affect motion in several ways. They can make objects start moving. They can make objects move faster, move slower, stop moving, change direction, and change shape. Since forces cause changes in the speed or direction of an object, we can say that forces cause changes in velocity. So, forces cause acceleration. Remember, we learned about acceleration. It was on our last test. In 3 ways: speeding up, slowing down, and turning. Okay? So, forces cause that acceleration. Forces are measured in newtons, which is a capital N. Forces usually act in pairs. Forces act in a particular direction. And forces usually cannot be seen, but their effects can. With these drawings, these diagrams, you need to label the force in each picture as a push or pull. So with the rocket, we would type in, or we would write in push, because it is pushing. And then the second part is you have to describe whether the force is causing a change in speed or direction or both. So with the rocket, it's a push, changing in speed, accelerating upward. So it is going to be both, because it's changing the speed and direction. Okay? You're going to do that. You're going to explain those two things, identify both things with this parachute, the person in the rock, the seesaw, and the boy playing golf. I recommend you stop the video so that you can do this. Now, more than one force can act on an object at a time. The forces can push or pull in any direction. What happens to the object when the forces act depends on 2 things: how strong the forces are and the direction of the forces. When more than one force acts on an object, the forces combine to form a net force. The combination of all the forces acting on an object is the net force. Forces may work together, or they may be opposite forces. So in other words, if you're pushing together, then you're working together. If you're pulling apart, like if we're both standing here and we're trying to pull on a string in opposite directions, we are not working together. We're fighting against each other to get it. Or think of a little kid with a toy, 2 little kids with toys, and they're fighting over the toy. They're both going to be pulling in opposite directions. Okay? 2 or more opposite forces are balanced forces if their effects cancel each other out. Okay? And that means they do not cause a change in an object's motion. If 2 forces of equal strength act on an object in opposite directions, the forces will cancel, resulting in a net force of 0 and no movement. Think about these boys. It looks like they're trying to do like a tug of war. They're both pulling with the same amount of force, with the same equal strength and everything, in opposite directions, so there's no movement. Neither one wins. If one of those boys were to let go, that's another story, okay? But right now, they're both pulling on it with the same amount of strength, and so they are not moving. That means the net force is 0, and it is balanced. Now, if the effects of the forces don't cancel each other out, if one force is stronger than the other, the forces are unbalanced forces. Unbalanced forces cause a change in motion, speed, and or direction. Okay? These 2 boys, if one of those boys were to let go, then the other boy would fly back with the board. They would win because they would have more force, right? Okay, but when 2 forces act in the same direction on an object, the net force is equal to the sum of the 2 forces. So if both of these boys were on one side together trying to pull something, then they're going in the same direction, so we would add the 2 numbers together, okay? When 2 equal forces act in opposite directions on an object, the net force is the difference of the 2 forces. So in this case, if one of these boys was bigger than the other, the bigger boy, let's say he was 20 newtons, the little boy was pulling with 10 newtons, then we would subtract those 2 numbers, which means the net force would be 10 newtons, and it would be to the direction of the bigger boy, okay? The final force in this direction are called a resultant. Now, when you're looking at this diagram, we have 1,000 newtons. those people on the left are pulling with 1,000 newtons, and on the right, they're also pulling with 1,000 newtons. So are we going to get a winner in this tug of war? No, right? We have to decide, are they pushing or pulling? That's the first thing we have to decide. Are these guys pushing or pulling? In this case, they are pulling. They're both pulling in opposite directions. So they're not working together. The forces shown above are in opposite directions. They're not working together. So are these equal? There's 1,000 newtons on the left, 1,000 newtons on the right. Okay, so you need to decide, is that equal? Do the forces balance each other out? Do they or do they not balance each other out? Is somebody winning? If they're winning, then it's not balanced. If nobody is winning, if it's not moving at all, then it would be balanced. Now, the resultant force in this case, remember, we learned earlier that if it's the same amount of force on each side, and it's balanced, then it is going to equal out. Okay? If the people on the right had been pulling it and it went their direction and they were pulling with the larger force, then they would have the resultant. But in this case, look at it. It's 1,000 newtons on the left, 1,000 newtons on the right. So you decide. And then, is there any motion? Is it going either way? On the second example, we have 200 newtons on the left, 100 newtons on the right. So now, knowing what we know, we have to about balanced and unbalanced forces. If it's balanced, they're equal and cancel each other out. If it's unbalanced, they're not equal, and one side is going to be stronger than the other. So our questions here for number 7, the forces shown above, are they pushing or pulling forces? Are they working together or against? That's the second question. Are they working together or opposite forces? Are the forces equal or not equal? Remember, the one on the left is 200 newtons, the one on the right is 100 newtons. Do they balance each other out? Number 11, the stronger force, is it pulling to the right or the left? And remember, it's the stronger force if it's the bigger number. The weaker force, is it pulling to the right or left? And the last one is, which direction is the motion, right or left? Which way is it going, the right or left? Showing forces. Now, showing forces, a force can be shown with a vector. A vector is a line with an arrow. It begins with a dot. The dot shows where the force begins. The length of the arrow shows the amount of force, and the arrow shows the direction of the force. Okay? Let's look at this. Each square represents force of 1 newton. This vector shows a 5 newton force to the right. So you put your dot here, and we're going to count. 1, 2, 3, 4, 5. That means there's 5 newtons force, and it's going the direction to the right. Okay? These can either go right, left, up, or down. Now, you're going to see this chart over here to the right. Remember, each one of these boxes represents 1 newton. Okay? So let's look at number 1. We've got 1, 2, 3, 4. So in the box right here, you're going to put 4 with a capital N to represent newton. Then we have to decide, is it going to the right, left, up, or down? In this case, it is going to the right. So you would write the word right. Number 2, let's look at that one. We're going to count. 1, 2, 3, 4, 5, 6, 7. So in this box right here, you're going to put the number 7 and a capital N for newtons. And then, is this going up, right, left, up, or down? It's obviously going down. So you're going to write the word down. You need to finish 1 through 10 on this page. When we go down here, now they want you to draw them. You're going to start by putting a dot. And in this case, we're going to go 7 newtons force to the right. So our dot goes here, and we're going to count our boxes. 1, 2, 3, 4, 5, 6, 7. In this box, in the 7th box, you would put your arrow that points to the right. Okay? You're going to complete that page. Now we have to figure out the resultant. The figure to the left shows two opposite forces. There's a 5 Newton force to the right, and there's a 7 Newton force to the left. In this case, they're opposites, so we have to subtract to decide the result. And in this case, it would be 2, because 7 minus 5 is 2. Okay? So we're going to go down here. The figure shows two forces in the same direction. If they go in the same direction, you add. So opposites subtract, same direction, add. In this case, they're both going to the right, 5 each, so the total is 10 newtons force to the right. Now, what we're going to do down here, we have 6 sets of vectors shown below. Draw the resultant vector next to each set. Start at the dot. One has been done for you. So we've got this, it was 1, 2, 3, 4, and you see there's a chart down here. Okay, you're going to need to complete the chart. For number 1, how many forces are there? There are 2 forces. Okay, so you're going to write the number 2 under the total number of forces. The amount of force in newtons. So now we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because they were both going the same direction. That's why I just counted over. So it's going to be 14 newtons right here. What direction is it going? It's going to the right. So we're going to write the word right. Now our resultant is going to be 14. So we're going to have to put a dot, and we're going to count 14, and in our 14th box we'll put that right arrow, okay? So down here our resultant is 14 newtons. And then yes, there is movement. Because they are working together, it is going to move to the right. Now, if we look at number 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There are 2 forces, 1, 2. So you would write under number 2, you'd write 2. The amount of force would be 21 newtons. It's going to the right. Our resultant, you would draw starting here all the way across. You would draw all the way. You put your dot here and draw one big long line with the arrow pointing at the end. And yes, we do have movement. I want to skip down to number 4. Real quick. Number 4, they're going in opposite directions. We've got one going up, one going down. We need to count. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So that is a total of 12 newtons. So for number 4, you would put 2 forces, 12 newtons. Now, is there a direction, right, left, up, or down? No, because it's opposite directions. Now, if they both have 6 on each side, is there a resultant? 6 minus 6 is what? 0. So you would put 0 here for the resultant, and there is no movement. So that means, is it balanced or unbalanced? It's balanced, right? Because there's no movement. All right, so if they're going in the same direction or opposite, because it's 0, it's balanced. It's opposite direction, and they're both the same amount, 6 and 6. So 6 minus 6 is 0. Okay? So what you need to do is you need to finish this, making sure to draw your resultants, and good luck. See you tomorrow.